Hello, everyone, and welcome to the Ask the Expert webinar. How can synthetic data improve ML training and fairness? My name is Thiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenters. First is Sundaresh Sankaran, a senior solution architect here at SAS. Sundaresh helps organizations make better strategic and operational decisions through technology. We also have Erin McCarthy. She is a marketing, analytics, and customer intelligence strategist with over 20 years across corporate, nonprofit, and entrepreneurial settings. And finally, we have Natalia Spicer, a product manager here at SAS. Natalia is specifically focused on Gen AI and cloud/platform products. Why don't we turn things over to our presenters so we can get started? Natalia, please take it away.
Hello, everyone, and welcome. I will try to match Thiago's energy here as much as I can, but hopefully you're all energized and ready for this awesome chat that we have presented for you. So here's our plan for today. I will talk about why synthetic data has become so important and where SAS Data Maker, our product that I represent specifically, fits into this. Erin, she will cover the data challenges that organizations face. And when we get to Sundaresh will walk through ML and fairness implications, and also he will show you Data Maker demo, which I'm sure you're all excited to see. So we'll leave plenty of time for questions at the end, so feel free to note them as we go. You can post them in the chat, or we can answer some of the questions at the end as well, live. So let's go ahead and get going. All right, so as Thiago introduced me, I'm a product manager for SAS Data Maker. And today I would like to briefly cover three things: what synthetic data is, why synthetic data importance is accelerating now, and also how SAS Data Maker, our product, fits into that picture. We're clearly in the AI era. I'm sure you all agree with us. Investment is very high and adoption is widespread. But AI innovation is moving faster than data governance processes. And I'm sure you all can agree with this by looking at the slide and some of the numbers that we have here for you. But despite heavy investment in AI, most organizations are still constrained by basic data challenges. And hopefully you guys can relate here. Some of those are data is hard to share, it's expensive to collect, it's incomplete, and often restricted by regulations. These issues slow experimentations, and it limits model quality, long before algorithms become the problem. Data has always been important, right? I'm sure you guys agree with that. We all use data. But what changed? What changed is how constrained real data has become. Privacy regulations, access control, data scarcity, and now some of the biggest blockers for the AI progress, right? Hopefully you guys agree with this one. That's why synthetic data has moved from a niche concept that it was before to a practical capability that most organizations are actively exploring. And this isn't about replacing real data though, right? That's not what we're talking about here. It's about making data usable. When real data is restricted, scarce, or biased, right? This is when we need synthetic data to come and rescue us. It really is a whole new world with AI these days. I mean, you guys seen the news, you've been using it. It's a new world for sure. And for customers and for producers, or for consumers and for producers, on both sides. In speaking with our customers here at SAS and different organizations across different industries, we consistently hear curiosity around what synthetic data can enable. Teams see the promise, but they're still figuring out where it fits. But what we found is that customers tend to fall into three general positions when it comes to the value of synthetic data. So number one, I need access to data, but I can't use real data. So these teams are blocked by privacy, security, or regulations. Synthetic data here is often the only way they can safely analyze and share data at all. When we talk about number two here, and these teams say, I have data, but it's not good enough to train models. So here, data exists, but it's incomplete. It's biased or missing edge cases, So synthetic data is used to improve quality and make models more reliable in this case. And number three, I want to move faster without waiting on governance and production data. So this group is driven by speed, obviously, right? They need to move fast. Synthetic data lets teams experiment and build in parallel without waiting on approvals or production pipelines in this case. So across all three, the common theme is the same. Customers want data that they can actually use safely, effectively, faster, and that's exactly where customers find value in synthetic data. So hopefully you guys agree with some of this and can relate to some of these questions and statements. All right, so this is where SAS Data Maker comes in. Its goal is to elevate innovation, productivity, and data quality using trusted synthetic data. Let's talk more about this. So the premise here is simple. Organizations usually face one or both or two data challenges, right? So the first one that you see here, they need safer data. This is most common in regulated industries. And when we talk about regulated industries, we're referring to banking, healthcare, government, right? So those type of industries. They have valuable data, but privacy rules and compliance risk prevent them from using or sharing it freely. And so SAS Data Maker lets these organizations generate synthetic versions of the data. So their team can analyze, test, and collaborate safely without exposing sensitive information in this data, right? In many cases, synthetic data is the only practical way these organizations can move forward, really. The second one that you see here on the screen is teams need augmented data. Other organizations do have access to data, but it's often sparse, imbalanced, or it's missing key scenarios. So think about fraud detection, or think about predicting machine failure. These are rare events, right? So, and it's hard to train good models without enough examples. So if we talk about SAS Data Maker allows teams to augment their existing data with synthetic records to fill those gaps and improve model performance. In both cases, on the right and on the left, synthetic data is the enabler here. At a high level, let's talk a little bit more about SAS Data Maker. SAS Data Maker removes the traditional trade-off between innovation and risk. Teams can move faster because they don't need access to real production data to start experimenting or building models, right? They can start right away. They can scale because synthetic data helps address data scarcity, and it lets them reuse and augment what they already have at much lower cost, which is a big one here. And critically, they can trust the data because it's privacy preserving and still behaves like real data. And the result, fast innovation, better models, and privacy protection at the same time. So once organizations remove the trade-off between innovation and risk, the next question is, how quickly and easily can they actually get started with SAS Data Maker, right? So that's where SAS Data Maker really stands apart. SAS Data Maker is our first standalone, cloud-native synthetic data offering. It's available directly through Microsoft Marketplace. It's fully managed and doesn't require any other SaaS products, so you can get started right away. Customers just deploy it in the Azure tenant, and the experience is intentionally simple. It's intuitive, it's scalable, scalable workflow that teams can use without any deep experiences. And because it's standalone, it's great door opener as well. It's low friction, low barrier to entry, and fast way for you to start seeing value from SaaS. In short, it makes it easy for organizations to safely innovate at scale from a day one. Let's explore a few use cases supported by synthetic data and by SAS Data Maker. Spanning industries from fraud detection and clinical trials. Just dive a little bit deeper in this. So the common thread across all of these is enabling AI where real data is limited, restricted, or difficult to use. From industry perspective, synthetic data is relevant everywhere, but it's especially valuable in high regulated industries, as I mentioned earlier, like financial services, you can see here, healthcare and life and sciences, government, manufacturing. In banking, for example, teams using synthetic data for fraud detection, risk modeling, and climate-related risk scenarios. If we talk about public sector, it supports policy development, law enforcement, simulations, and much more. When we jump into healthcare and life and science sector, synthetic data accelerates clinical trials, and that's a big one. And it also enables secure health information exchange. In manufacturing, if we talk about manufacturing industry, it's used for predictive maintenance and for work safety by simulating failures in hazardous conditions, excuse me. Across industries, synthetic data powers core AI needs. It's filling data gaps, it's enabling safe data sharing, reducing bias, scaling model training, and preserving analytical value without retaining sensitive records, of course. So the key takeaway here is this. Synthetic data isn't just a compliance tool. It's an innovation enabler across all AI workflows. And let's talk a little bit about our customers and what they say about SAS Data Maker. We constantly hear that SAS Data Maker is easy to use, it's fast, and it gives teams confidence in the quality of the generated data. That confidence is critical, and I'm sure you guys agree with that, especially when synthetic data is being used to inform real decisions and also save lives. Think about that. Thank you, guys. And next, I would like to welcome Erin McCarthy, our product marketing expert. She will take you through solving data problems and challenges.
Great, thank you, Natalia. Can you guys hear me okay? I think so. So I'm going to go through a couple of our data challenges and talk about some privacy enhancing techniques and what you should consider when using synthetic data, how the different techniques look, and why Data Maker is a great choice for your synthetic data. I'm also going to take a minute here to encourage everyone to submit your questions into the Q&A. You can ask us questions about anything you're thinking about synthetic data, whether we're covering it or not. If you've got questions, stick them in the Q&A. So please feel free to get started with some questions. So how does synthetic data help organizations overcome their most common data challenges, both quickly and securely? First, synthetic data enables data sharing. So teams can share data sets that retain the statistical properties they need without exposing sensitive information. So this makes collaboration across business units with third-party partners, external partners, or even across international borders much easier. Second, it helps you reduce the cost and effort of data collection. Synthetic data can be generated programmatically, which means less time spent on expensive data acquisition and storage. You can accelerate your AI deployment by utilizing synthetic data versus waiting on data files to be created. Third, synthetic data is a powerful tool for augmenting and balancing data. It can fill gaps and simulate rare events, help models learn from scenarios that are underrepresented in your real data. And all this is critical for effective machine learning. Finally, synthetic data simplifies privacy and compliance. It mimics real-world patterns without exposing real-world records. Teams can use data more freely while still respecting regulation and government requirements. Together, these benefits explain why synthetic data shows up across all three customer positions, whether your goal is to access better training data or faster innovation. Synthetic data is fundamentally different than and used more often than traditional anonymization techniques. Interesting fact here is that, based on knowing gender, zip code, and date of birth, 63% of the US population can be identified. So this demonstrates why synthetic data or other techniques for privacy enhancing techniques is critical to use in your analysis. Common approaches like randomization, permutation, generalizations, and pseudonymization are ways to address this. These methods attempt to protect your privacy by modifying real data, but they can still retain a direct link back to the original records. As a result, they come with higher re-identification risks and significantly reduced usefulness for machine learning. Key statistical properties and feature correlations are also frequently distorted, which limits how well models train on the data and how they perform. Synthetic data takes a different approach. Instead of altering real records, it trains the model to learn patterns from the data, and then it generates entirely new records. That's why you see low re-identification risk, and you're still preserving the feature statistics, correlation, and usability in your machine learning models. A key takeaway here is that synthetic data isn't just about masking data, it's about enabling meaningful analytics and machine learning without exposing real people or sensitive records. So let's take a closer look at some common privacy enhancing techniques and examples of what the data structure looks like. Real data is great. We've used it successfully for years, but it's expensive to collect and store, and we might also have storage limitations as well. Using real data has inherent privacy and security risks, particularly if you're sharing externally, but even internally it can introduce unnecessary security risks. Anonymized data is real data that's been altered to achieve a level of privacy. By comparison, pseudonymized data takes that one step further and replaces customer identifiers with artificial identifiers, and you use a key to map back. But that key in and of itself becomes a security risk because you can re-engineer if you have access to the key. Synthetic data overcomes all these privacy concerns as it's completely generated and cannot be re-engineered to the original data set. Other common techniques people might use are randomization to control the controlled noise entered into your data set, aggregation, which is combining individuals into combined groups for analysis, or permutations, which is shuffling around your data structure. Now we're going to take a closer look specifically at synthetic data and what makes it stronger than the rest of these applications. Synthetic data is extremely useful for a variety of applications when your data is too sensitive to share, either internally or externally, when you don't have access to real production data, or when your data is sparse or insufficient. Other examples would be when you're dealing with rare events or edge cases, when your data is highly imbalanced or biased, or just when you need data for a variety of testing scenarios. Some other examples would be cross-border or cross-team collaboration, or if you're building models for benchmarks and comparisons. Some quick rules of thumb are use synthetic data when your privacy risk is high and security is critical, your real data is limited, restricted, or slow to access, you have rare events or imbalanced subject matter, you need to share safely, or if you need data for testing and early experimentation. Now we're going to take an even deeper dive looking at synthetic data compared to anonymization and when you would use each. These are the two top techniques for privacy enhancing technology, so we'll take a deeper look comparing the two. Synthetic data is AI generated, so it reflects the inherent properties of your underlying real data, but it can be highly safe without sacrificing model results. By comparison, anonymization is less secure because it can be re-engineered, but it does retain the statistical rigor of the original data set. So let's look at the strengths and weaknesses and trade-offs between the two. With anonymization, you're using techniques like masking and aggregation. Again, the biggest benefit is you retain that utility or fidelity to the real data set. The downside, again, is that there's still privacy, security, and re-identification risks. Because it's re-engineerable, there will be higher regulatory scrutiny on it. It's best to use for internal analytics, testing, or times when you need to balance utility with privacy or security concerns that aren't as great. In comparison, synthetic data is AI generated. It's highly secure with zero chance of re-identification. It can have lower model efficacy, but it can require significant computational power and resources. It often requires statistical and programmatic knowledge and skills. It's excellent for model training, external data sharing, privacy-first use cases. So here's a side-by-side comparison of what we just discussed. So I just left this for you as a comparison chart. We don't need to go over it since we've already covered all of it, but it just gives you the strengths and weaknesses to look at when you would use anonymized data versus synthetic data. And just to boil all of this down, anonymized data is real redacted data. Synthetic data is new data generated to mimic your original data. Synthetic data is considered to be safer and more compliance friendly. You would choose synthetic data when you need the highest level of privacy and security. You might choose anonymized data when realism is your top objective and privacy risks can be mitigated. But here's where Data Maker comes in. Its goal is to elevate innovation, productivity, and data quality using trusted synthetic data. SAS Data Maker offers a high level of security and privacy. It allows you to reduce the bias and create more ethical and trustworthy production models. It offers strong statistical validity with methods and reporting to ensure high quality results. Because the compute is cloud-based, Data Maker is highly scalable. It's very easy to use because it's got a low-code, no-code user interface, and you can confidently leverage best-in-class statistical techniques, evaluating the efficacy of your synthetic data. It also provides auditing tools, and you can recreate results. So this overcomes all the disadvantages normally attributed to synthetic data. You don't need specialized skills and training. You're not going to need additional hardware investments for your infrastructure. And you're not limited by the computational power of your infrastructure. So it's a win-win all the way around. Now I'm going to turn it over to Sundaresh Sankaran. Sundaresh is going to go through and show you what the process looks like, and then give you a live demo of SAS Data Maker in action.
Great. Thank you, Erin. Thank you. And I am here. Let me reassure you. I wasn't sleeping on the job. Don't read anything into the fact that I was leaning on the windowsill for the past 10 minutes, which just admiring the view. So we're going to talk about synthetic data and how it is applied to lead towards better machine learning outcomes. Now, before that, let's take a look at what it actually takes to really generate synthetic data. You've all heard the word data maker being bandied around, synthetic data, but it's important to understand how exactly this application works in enterprises. And that's a key word, because forget about the fact that you explode generating synthetic data, creating models that help you generate synthetic data. The point is, when it comes to enterprises, there are a whole lot of regulations and role-based access controls that come into the picture when we deal with data. Just yesterday, I was at a data analytics conference, and while chatting with one of the other attendees, I got to know that in certain regulated industries, highly regulated industries, even data engineers whose job it is to actually query data, transform data, they sometimes get asked questions regarding a particular data set which might contain sensitive observation, identifiable observations, and they are asked to justify why did you touch that data. So you can see as on the right-hand side, on the left-hand side of this chart here, there are folks who have privileges to access data, real data within an enterprise. And this data is not one single data set. It's multiple data sets which needs transformation. It needs to go through a whole lot of pre-processing. And finally, after that, it needs to pass down to other members of the same organization whose job it is to consume data and carry out downstream applications such as modeling, carrying out testing, production testing, volume testing, stress testing, and scenario generation. So there are producers of data and there are consumers of data. Now, consumers of data generally do not have all the privileges when it comes to accessing data that might contain sensitive customer-related information. Keep in mind also that sometimes these enterprises are not the owners of the data per se. They are custodians of the data. These original data points and attributes have come over from customers. So it's incumbent upon the enterprises that they take care of original data, production level data, and ensure that only synthetic copies which contain minimum relevant information get passed down to consumers. That's why we need an application which helps us generate synthetic data rather than just calling a procedure offhand during the middle of a project. So if we were to watch Data Maker work, do its magic, synthetic data in action, first let's start at the source level. When it comes to data, and data is aggregated in various analytics platforms, it's usually surfaced through various retrieval mechanisms, such as a search mechanism, as you can see here. So imagine that in an organization, customers search for various data assets, and these could be one data set, these could be multiple data sets. All of these tend to have various degrees of sensitive information in them. And it's possible that sometimes you might need to have to understand what exactly is in this data, what exactly are the characteristics of the data before releasing it for downstream analysis. That's where it's really important to adopt a process-based mindset. First, understand what are the sensitive elements that are to be found in data. Take decisions and start off workflows that review data sets that need to be released for analysis. And once you review them, once you understand that there are certain elements such as name, address information, you might not really want to release it to a downstream data scientist because their job is to fit a model. They don't really need to understand how to identify a customer. But you might want to release it to an application test engineer because they might want to carry out volume-based testing on real-world scenarios mimicking this sort of information. So the idea is that you take decisions on what sort of data you're dealing with, take decisions on how to transform this data, and then make use of automated mechanisms to flag this data and make it available for synthesization. So that's where Data Maker comes into the picture. Data Maker, as you can see here, is a standalone application. It is an application that runs on Microsoft Azure. It takes into account data coming in from various sources within specific governed projects. It helps you train an abstraction called a generator. And that generator is trained using machine learning methods. It's a model which consumers of synthetic data can call today, tomorrow, 10 months down, anytime they wish to generate synthetic data. So let's take a look at what Data Maker actually does. Data Maker allows you to generate synthetic data. That much we know. The end result is as follows. You have a data set comprising various individual data files, each of which relates to different aspects of customer behavior. You wish to train a model. So first, you need to provide your data scientist a synthetic copy of that individual data sets. It's better if it's provided at a granular level because the data scientist has that much more flexibility and freedom to carry out additional data engineering activities. So as you can see, we have obviously provided that. We have provided that to various degrees of data volumes that a data scientist might request. They might be happy with a whole lot of data because they can use it to do their job, which is to fit models. But how exactly did we arrive at that? Well, walking backwards, original data is first presented to Data Maker through a project. And Data Maker automatically infers relationships among these different data files and creates what is known as an entity relationship diagram. This entity relationship diagram identifies core aspects of every data file, the columns that are contained in those data files, and also helps you determine whether some data files are related to a point in time, some others are over a period of time, meaning they are time series or transactional data, and some others are reference data, which does not necessarily need to be synthesized, but come along for the ride. Example, a list of branches or a list of warehouses that you would have. Examples of transaction data, data that flows into a bank as a result of many transactions that customers have. Examples of snapshot data, your characteristics at a point in time. So taking this data into account, and after finalizing the data configuration, you carry out a whole set of models. A key aspect during this model training process is to ensure that you input parameters that help the model achieve two things. One, obviously, it needs to create synthetic data that is as similar as possible when compared to original data. But at the same time, you do not want to run into data leakage issues. That's what Erin had emphasized to no small detail. So that's where you are given a choice to implement techniques such as differential privacy, which injects some random noise in the data during the training process and make it sufficiently different so that the end output does not allow you a means through which you can reverse engineer your way back to original data. You may not find that secret sauce right up front. You may have to carry out multiple iterations and assess the results that you get when it comes to running an iteration without differential privacy, running an iteration with different parameter values, and then with differential privacy applied to varying degrees. You find your sweet spot through all these metrics, which help you evaluate the goodness of fit for that synthetic data. Meaning, is this generator fit for my purpose? Your purpose, your end case might vary. For a machine learning engineer, for a data scientist, usually it's important that the synthetic data is as similar as possible to the original data. That's where there are a range of metrics which tell you how similar synthetic data is to original real data. That's all very good. You can even get very granular and access this information at a column by column level, looking at the overlap of source data, synthetic data, and the intersection between the two. But at the same time, your data scientist nobody wants to get into data leakage and compromise issues. If certain metrics that relate to disclosure or privacy risk are high, that's a danger sign. That means there is a degree of pre-identification risk that exists in this synthetic data generator that has been trained. And that's why it's important to experiment with differential privacy and try and increase the disclosure metrics to acceptable levels. So this way, as you can see, it is a process. It is a process that involves iteration. It's a process that involves applying judgment, not just clicking on a button and hoping for the best. So once you identify that sweet spot, that's when control shifts over to the consumers of synthetic data. Those folks, those are the end users, the consumers, the data scientists, the testing engineers, the decision engineers who want to use the data. They don't care too much about the intricacies of how the generator was trained. What they need is confidence that the generator was trained and it's fit for purpose, their purpose, and they want convenience in terms of being able to quickly provide a target destination and provide a given volume of records that they need for their downstream application. That's how they arrive at the end result, synthetic data that can easily be downloaded or accessed through APIs into an analytical platform for further analysis. And how is that analysis carried out? That's where it's really important to understand end applications of synthetic data. You can take into account synthetic data and use it as a hold-up sample. Now, some of you might ask this question, why don't I just go ahead and use that as the base training data? You can. It all depends on policies. Some organizations like to implement a policy wherein their data scientists can append synthetic data and original data together and then analyze them to see if the appended data set provides better results in terms of accuracy measures and other model diagnostics. Some others would like to continue working on original data, which might have been limited in nature, but they have the added advantage of being able to access synthetic data and carry out testing to a wider degree of volume. So that's the value that synthetic data provides you. So when it comes to what do we gain, finally, end of the day, we know how to do this thing, but how do we really assess how synthetic data generation affects machine learning outcomes? I think we'll have to look at three aspects. One is realism. How real is synthetic data? How applicable is it to end use cases? That's why you need to take into account multiple aspects. There's a big bunch of, proportion of users who say, I'm happy if synthetic data is similar to original data. That's great. But at the same time, there is this underlying concern about protecting risk. And that's where enterprise level synthetic data generation, organization level synthetic data generation comes into the picture. You don't want your synthetic data to be too similar to original data sometimes. Synthetic data generation could be a case which gives you a signal that you need to go back and take further steps for protecting your data before carrying it forward for machine learning analysis. And at the same time, there's one more subset which says, hey, you know what? I'm sometimes happy if it's not too similar to original data. I want some change. I want some randomness injected into the process because I want to account for the unknown. So allow me some creativity. Let me tinker with the differential privacy settings. Let me get data that's sufficiently different instead of sufficiently similar. So that creativity also needs to be accounted for. At the same time, that creativity should not lead to data that's absolutely has no relation to your original data trends, and therefore rendering your entire downstream analysis useless. So there are the need of guardrails. You evaluate your synthetic data, understand, does it serve your purpose rather than, staking your hopes on one particular metric. Second aspect, how does synthetic data ensure fairness? It might help you get more data and might improve your model, but how does it help ensure fairness in artificial intelligence? For this, we have to understand that fairness is just one aspect of a wider paradigm known as trustworthy AI. And trustworthy AI indicates that you should apply AI, carry out techniques that operate in an ethical manner and does not lead to further harm. Now, what we are dealing with here are serious issues of data leakage, privacy, compromise, which have serious repercussions in the real world. Synthetic data is an efficient way of protecting yourself, not protecting yourself from liability, but protecting the actual consumers whose data attributes we are playing around with here from harm further downstream. Synthetic data generation, if done in a safe way, will help you not only protect data, but also help you understand the true impact of your analysis. It gives you freedom to experiment, create different scenarios, and that helps you answer this question of not just can I create a machine learning model, but should I create a machine learning model in a particular way, which perhaps right now might be biased in favor of one group over another? And is that a good outcome? Most of the time, maybe you would be better off looking at the end purpose through a different lens. And finally, at the overall level, all of these help us experiment. And this helps us enable responsible experimentation rather than just coming out and releasing first and then worrying about failures later. The third and most important aspect would be, finally, end of the day, I use synthetic data for a downstream purpose. Does it actually add value to analytics? You have noticed how we can use synthetic data. You have a choice of using it downstream as part of your direct training data set, or you could use it as part of a holdout sample for testing purposes. We have seen empirical evidence. For example, a bank in the UK, which we work with closely, has actually used synthetic data in both cases, either as a holdout sample for testing purposes to assess their credit scoring risk models to a higher degree of scrutiny, or also using it as the actual training data. A combined effort based on a mix of augmentation, a mix of carving out a holdout sample, and also having a parallel data set for training purely on synthetic data helped this bank achieve a 28% improvement in model accuracy. Remember, this is not a magic bullet that's directly enabled by synthetic data alone. It is a result of applying synthetic data in a judicious way. The other aspect is that consider not just one model in its isolation. That's a mistake that we are all prone to making most of the time. There are many solutions, many analytical solutions, all of which rely on production data at runtime. But before they get promoted, they need to go through various rigorous processes of testing and validation. And that's where synthetic data actually comes in and helps you carry out that validation. So those are the three important aspects to keep in mind when considering synthetic data. And it's important that you not only experiment, but you experiment responsibly. So that's where, if you wish to experiment fast, try and see how you can evaluate data and then take a decision on how you productionalize. Check out Data Maker. It's available on the Microsoft Marketplace, as you can see on screen. Log on to the Microsoft Marketplace, previously known as Azure Marketplace, search for Data Maker, and you will run across these two badges. You can also access Data Maker on our community site and read a whole lot of more blogs to a greater level of technical detail on various aspects of synthetic data generation. With that, I think it's a good time to move towards questions. I'll leave you with this QR code so that you can scan it and learn more about SAS Data Maker. Over to you, Tiago, and thank you for the time.
Yes, thank you. With that, we will be moving into the Q&A segment of the webinar. All right, now on to our first question here. Someone is saying, do we need to start with real data? Can't we start with summary statistics? For example, if an article in New England Journal of Medicine describes the characteristics of the population being studied, can this data be used to generate a synthetic data set with the same overall characteristics?
Hey there, I'm not one of the presenters you guys have met. I'm Sufyan, I'm a data scientist here at SAS, but I can pick this up. So essentially, currently, Data Maker does rely on having an input sample to derive all of the distributions for the various tables, the links between them, and all of the statistics that we pull into the generative models. However, we are currently working on an extension, I guess, to Data Maker that relies on the same overall structure, right? So you describe what's in your data, the D types, but then rather than select a model and let it do the job, instead you would describe the distributions you'd like to reproduce, and then the flow would work pretty much the same way. You just skip the training part because there's no training given that we don't derive any distributions. So there is something that we are working on. Don't have a specific schedule in mind, but is a thing that will be added to Data Maker shortly.
Yes. We would invite feedback, and thank you, Sufyan, for that answer. We invite feedback on, how to generate synthetic data, your needs when it comes to generating synthetic data through configuration. In such a case, we are not relying on actual production data, but we start off with a configuration sheet. It could be an Excel sheet, it could be some other specification, but that basically takes up the summary question, summary statistics, like the questioner referred to, and use it to generate distributions. It also involves imposition of constraints. So that's a very interesting parallel area that we're looking into.
Thank you both for answering that. We have another question here. Someone's asking, how does SAS Data Maker ensure privacy while maintaining analytical utility?
So we got those privacy protection metrics in there, those controls in there are mainly relying on a technique called differential privacy. As you can see there, differential privacy is regarded as a stronger form of privacy protection, mainly because it injects noise during the training process as opposed to other techniques such as anonymization, which primarily look at individual variables and tries to convert them to a synthetic proxy. Now, the danger in doing that is that you might think that you're covered if you just remove a column from your data set, or you just cover it with a set of X marks or redact it. But what happens is that there are other attributes which can strongly indicate a presence or a distance to a real world observation from your synthetic data. So to protect against that, we need to jumble up the works somehow. And that's what differential privacy does. Now, when you do that, there is always a trade-off between privacy protection, the extent to which you protect privacy, and utility of the data set that you do. Because in essence, you are jumbling up the data. So you need to take a look at those metrics, monitor them, and identify that sweet spot that helps serve your purpose.
Perfect. Thank you. Another question here. Can you describe a real or potential use case in the government space about using protected tax data for revenue forecasting or public policy formulation?
I'll go ahead and invite others to chime in as well. So that is a little specific application, but we do not have details which we can divulge right now. But we have been working with government agencies, and most of the time, the pain point that we have to encounter is a problem in data sharing. I'm sorry. So when you consider problems like the question describes, a case where there's data that comes into one agency, but that agency relies on data that might come in from a variety of purposes. Analysis is better served if it's shared, and this data is shared across multiple agencies because sometimes they have different perspectives on the same. Leave aside taxation and finance, there are other industries also with strong public oversight, things like healthcare, which have the same problem. You need to share data with research institutes, with other quasi-government bodies, but you cannot just share data as is. So that's where synthetic data really helps us implement that wall between real data and original synthetic data, which is very similar, but which can be shared across these agencies so that it can lead towards better consortium models and better overall prediction. So I agree, taxation is one area which definitely can benefit from synthetic data.
Taxation. Got it. Thank you. We have another question. Can synthetic data be used in PhD research and academic publications?
The answer is yes. And I was just waiting for others to also chime in, but we've had cases where we have discussed, and this happens primarily in the healthcare and life sciences space, where prior to publishing results in a journal, most of these studies, clinical studies, tend to be long drawn in nature. And you may not want to publish final results right upfront because they have to go through various stages of review. But at the same time, information, initial insights is valuable because it helps the community as a whole in terms of carrying out their analysis and furthering the cause of scientific research as a whole. So in those cases, journal publications typically accept a synthetic proxy if you have proven that you're taken adequate steps to capture the essence, but not reveal too much about a specific study or increase liability both for the publisher of the journal as well as for the contributing agency.
Gotcha. Thank
I would
you.
also add that in contexts where the PhD or the research in general is focused on data that is sensitive in any nature, getting access to the data might actually be an issue in a lot of instances. And so using synthetic data by the data owner can then facilitate the actual doing of the research, if that makes sense, because otherwise you wouldn't be allowed to actually access the data.
Thank you both. We might have time for one more question here. You might have touched on this before, but someone's asking, what types of data work best with synthetic generation today?
Structured data is something that I will say upfront. Structured data and usually a mix of categorical and structured data, because categories provide the dimensions alongside how you generate synthetic data. You can be quite specific to mimic the distribution for a particular level of a categorical variable. Where synthetic data still has a way before it can really be considered production grade would be in the area of free text generation. And I know that this is going to be a debatable point, given that we are living in the world of LLMs and large language models. Heck, we're generating synthetic data all of the time. But the problem is that generating free text really requires a lot of context, and the context needs to be relevant and specific to the question at hand. That actually implies a whole lot of access to local data and proper structuring of unstructured data, which is used as evidence for free text generation. There have been cases, for example, organizations in the hospitality industry wish to generate synthetic data mimicking customer reviews so that they can test their customer service processes better. Claims industries like to generate false claims, fake claims rather, so that they can carry out their claims adjudication process better. But ever so often, when they carry out these experiments, they find that the details are oddly too specific and too similar to real world reviews or customer complaints that have happened, because that's the data on which it was trained on. So you need to a whole lot more careful curation of the data before you can really use it for synthetic data generation on unstructured free text.
Perfect. Thank you. I'm afraid that's all the time we have for questions today, but if we did not get to yours, we will answer all unanswered questions in our follow-up communities post. Thank you for submitting your questions and for joining us today. On behalf of myself, Aaron, Natalia, and Sundaresh, and all of SAS, we really hope they enjoyed today's presentation. Thank you all. Have a great rest of your day.